Greetings, ladies and gentlemen. Talking about the fundamental theorem of calculus today. This is huge news. This is really good news for all of us, especially those of us who did not enjoy the amount of time it took to do the last couple nights' homeworks, because this is going to be amazing. All right, suppose this is the case. We'll let something be true rather than suppose it's true. Let capital F of x be the antiderivative of some function, continuous function. F of x, little f. All right, so use your imagination, pretend that's true. Bam. Then the following is true. Here we go. Check this out. This is amazing. This is amazing.
Hang on, I need something.
Okay, yeah. We just need to breathe because, are you guys sitting down? This is huge news. Yeah, okay, good. Sit down. Internet friends, I know you watch this standing up maybe. Sit down. Watch this. Here we go. Let's see. The definite integral from a to b of f of x dx, right? The thing that we just spent so much time doing work on. Check this out, is done. Drop the mic, walk off stage. So, what this means is that the definite integral can be calculated using antiderivatives.
What's the point of doing
Because you need to have an appreciation for the history of mathematics and understanding how it works beyond, so that way maybe someday you'll be able to figure these out for non-continuous functions using some other methods or practices.
Is capital F of B basically what you get when you plug B into the antiderivative of f of x?
You got it.
Okay.
So let's figure this out. Let's do an example and watch how awesome it is. Let's even do from 2 to 7 on, let's make it even a gross one, 2x cubed minus, let's say, 5 x, sure, dx. So what this is saying is, if I find the antiderivative of this function, I can then just plug in 7 and 2 and subtract them. And it'll be awesome. And we're actually really good at finding antiderivatives, if I remember. Well, I hope. Maybe. So let's figure out, so there's f of x. So what is cap f of x? Do you guys recall? So let's see. I would take the 2 and divide by, 3 plus 1 times x to the 3 plus 1 minus 5 divided by 1 plus 1. Yeah, I'm writing it all out, but you wouldn't have to. Times x to the 1 plus 1, right? So cap f of x, the antiderivative of x, f, would be 2/4 or 1/2, I suppose, x to the 4th minus 5/2 x squared. So, yeah, exactly. So let's figure out what is f of 7 and what is f of 2 is what we'll end up doing. And then we'll just subtract them. Isn't this great? Isn't this great? Good news, everybody. Good news, everyone, is what Professor Farnsworth would say when he's introducing the fundamental theorem of calculus to, say the cast of Futurama. So 1/2 of 7 to the 4th. Yeah, this is, still PEMDAS, really. Minus 5/2 times 7 squared. So let's see. 7 to the 4th. Yikes. That is 2401 over 2 minus 7 squared, 49 times 5. What's that? 245. halves. So that's going to equal 2401 minus 245 is 2156 over 2, which is 1078. So what does 1078 represent? That is the area under this curve from 0 to 7. Okay? So that's what this actually represents. So this is from a equals 0 to b equals 7, right? And now we'll figure out f of 2, cap f, right? Not bad, not bad. Man, this is so easy. I love it. Fundamental. Let's see. So that's 16 halves. I won't reduce that yet. 2 squared is 4 minus 20 halves. So it's going to be a negative number, actually. Negative 4 halves, right? Or negative 2. I don't think I made any errors. Yeah, so the answer is 1078 minus negative 2, 1080. Isn't this just like awesome? Good news, guys. Really good news. Math is not always super complicated. And now you can find the area under continuous curves very, very easily. Yeah, like that was like nothing, right? Crazy stuff.
Last time you sent us into this, it was like Marine training.
Yeah. I sent you to like math boot camp first, and now I was like, oh, guess what? You don't have to run anymore. You just get to drive this awesome tank robot. Right? Yeah, it's wonderful. So that's pretty cool. So you can do those. And then the other thing I got to tell you today about is indefinite integrals. Is pretty much just another way to refer to an antiderivative, where basically it turns out that the indefinite integral of a function is just that. That's pretty much it. Yeah.
Is the f on the left?
This is a lowercase guy.
Okay.
Sorry.
And the
So-
one on the right is capital?
Capital. Yep. So basically what that means is your function, the antiderivative, represents a curve whose y value is the area under another function from 0 to that point. All right, so a derivative represents the slope of another function, and the indefinite integral, or an antiderivative, those are the same thing in this case, represents the area under the curve of another function from 0 to x. All right, x equals a, or whatever it is. All right, so that is pretty cool stuff. And then, there's some properties, but they're really exactly the same ones. I'll snapshot them, but technically, I think this rule right here just summarizes it much better, because they're the same, right? So this is antiderivative rules, but we've seen them before, right? Good stuff. Actually, one more thing about notation is...
Are you writing that down?
No. Once you found cap f of x, sometimes actually what they'll write is, I might have written an intermediate step, just so you're aware of this. Maybe I'll write it in yellow. You also sometimes might see this, where if I wrote 1/2 x to the 4th minus 5/2 x squared, and then they'll have like this little line, and they'll have 2 and 7. Meaning basically like, here's the antiderivative that I calculated, and now we're just going to plug in 7 and 2, which is what we did. So that's just another type of notation. This is kind of like a tall absolute value bar, and it's just saying plug in 7, plug in 2, subtract them, is all it means. But I'm fine if you kind of do it piecemeal like this, where you find each part and then just plug them in back at the top, is also well. So, yeah, fundamental theorem of calculus. Who would have thought? Who would have thought? And then, yeah. I think we should just go ahead and do some partner work. I don't think I need to complify this any further. So, thanks, Internet friends. Enjoy. Bye-bye.